Good afternoon, students. How are you? Today we will start next chapter of class 10th math arithmetic progression. In short form, we can say AP. Till now we have done 4 chapters, and in fourth chapter we have done quadratic equation. How can find out the roots of the quadratic equation? By two methods given in your syllabus. One is the splitting the middle term, or you can say factorization method. And next is given quadratic formula. With the help of quadratic formula, you can find out, you can solve every quadratic equation. But splitting the middle term, you can solve particular quadratic equation which satisfying b square minus 4ac is greater than or equal to 0. And if b square minus 4ac is saying discriminant which is less than 0, it's meaning real root not exists. So that's not our work. We don't know about which number are not real. Till class 10th, we know all number which are real. Later on, it's divided into another parts also complex number. Real part plus imaginary part of a number. Both we can join, then it's become a complex number. But that's later on. So now we can start next part of this next chapter of this class 10th, chapter number 5. So here what's given? Introduction. Given you must have observed. So giving an example from the nature, that in nature many things follow a certain pattern. So many things following certain pattern. Pattern meaning rule. Such as the petal of sunflower. Petal of the sunflower, you understand, Surjamukhi ki pankhudi. They are following a rule. Following certain pattern. You have seen also, not seen, I don't know about this, but their color is yellow, following a particular rule. The holes of a honeycombs, the grains on a maize, मक्के का भूटा जिसको हिंदी में बोलते हैं, that's also following a certain rule. The spiral on a pineapple and the pine cone, etc. These are the examples given. So beta, before starting this chapter, we must know what is sequence. What is sequence? Sequence is an arrangement. What's sequence? Is the arrangement of things which following a particular rule. Particular rule. Like this example, I have taken 3, then I have written 7, then I have written 10, then I have written 17, then I have written 27, then I have written 44. Next, what's coming? Easily you can examine. So it's following a pattern, it's following a rule. So this is a sequence. First term 3, then 7, then sum of these 10, then sum of these 17, then sum of these 27, then sum of these 44, then sum of these coming. You know what's coming here, what's coming here. This is saying sequence. Sequence also many parts. So what's the definition of sequence? Arrangement of things in a particular order. Understood? But another example also given in this chapter. This is Reena applied for a job. One girl named Reena applied for a job and got selected. She has been offered a job with a starting monthly salary of how much? Saying starting salary how much? 8,000. Then with an annual increment of 500 salary. So after 1 year, what's her salary? This. After this, this. So after this, then this. So this is also a sequence. This is also a sequence. Easily, we have to add 500 in each. But this type of sequence is known as AP, arithmetic progression. Here, difference between the succeeding term and precedent term is always equal, always same. Understood? Look one time. First term is always saying in it A. Understood? This is A1, A2. What is this? A3, A4. If anybody is saying find out A5, so easily we can say A5 is equal to 10,500. Yes or no? But I want to tell this. So this I have written A5 is equal to 10,000 plus 500. And this is their difference. A1 minus A0 is equal to 500. A2 minus A1, 500. A3 minus A2, how much? 500. So this is saying D. D mean common difference is 500. What's common difference? 500. So A5 we can write A, this is 10,000 what? This. A4 plus D. Understood? And A4, how can we write? A4, this equal to A5 is equal to A4, how much? Plus D. Then A5, this we can write like this if you are having no problem. So A5, what is this? A3. What is this? D, D plus D. Understood? Then again write A5, A3 is what? This. Plus 2D. This we can write, how can? What is this? 9,000? A2. What's this? A2 plus D is this. So 3D. Then this we can write A5 is equal to A2, 9,000 plus 3D. This we can write 8,500 plus 500 plus 3D. So A6 is equal to how much? 8,500. What is that? A1 plus this is D, 3D plus 4D. Then what? A7, sorry, A5 coming here. A5 is equal to A1. What's A1? 8500 plus 4D. 3D plus 1D. So in this way we can find out. At last what formula we come? AN equal to A plus N minus 1 into D. Or we can say like this, this is A1, this is A2, this is A3, this is A4. So taking an example in this way we can take. So we easily understand. But this we can take later on. Now telling about a sequence. A pair of rabbits are too young to produce in their first month. So produce their young one after 1 month. In the second and every subsequent month, they produce a new pair. This produce, what produce this? Next month, this produce this and this produce this. Understood, written this. Similarly, then again this produce this, and what? This produce this. So in this way, write 1, 1, 2, 3, 5, 8. Following a rule, 1 plus 1, 2, 2 plus 1, 3, and 3 plus 2, 5, 5 plus 3, 8, 8 plus 5. Here 13 coming easily we can. Understood? What is this? A, 2, 3, 5, 8. We can say this is A1, this is A2, this is A3, A4, A5, A6. So what's A2 minus A1? 1 minus 1 equal to 0. A3 minus A2. What's A3? 2 minus 1, which is equal to 1. So these both are not equal. So we can write A2 minus A1 not equal to A3 minus A2. What's its meaning? These are not in AP. This sequence is not in AP. But this is a sequence. Easily able to write next term. What's coming? 21. What's coming? 34. And sequence also two type. Finite sequence and infinite sequence. If sequence contain finite number of term, then finite sequence, and if contain infinite number of term, then infinite sequence. In the same way, AP, if contain finite number of term, finite AP, and if contain infinite number of term, then what we can say? Infinite AP. So we can say AP is a part of sequence. AP is a part of sequence. And easily we can decide this is in AP or not. Arithmetic progression, consider the following list of number. So look one time. 1, 2, 3, 4. So we can say A1, 1, A2, 2, A3, 3, A4, 4. So find out A2 minus A1, 2 minus 1, 1. A3 minus A2, A3 minus A2, 3 minus 2, 1. A4 is A4 minus A3, sorry. Is equal to A3 is equal to what? 4 minus 3 equal to 1. So look one time. A2 minus A1 equal to A3 minus A2 is equal to A4 minus A3 is equal to 1. Is equal to 1. Yes or no? Yes or no? So the given sequence in AP. And this difference is what saying? This common difference is saying D. D is stand for common difference. So arithmetic progression, consider the following list of numbers. So what's coming next? 5, then 6, then 7, then 8, then 9, then 10. Second given to you. What's given second? Second part. A1 100, A2 70, A3 40, A4. Okay. So find out A2 minus A1. 70 minus 100 minus 30. A3 minus A2. 40 minus 70. How much? Minus 30. A4 minus A3. 10 minus 40. How much? Minus 30. Look here also. Common difference is same. So these are in AP. These are in AP. What's D here? D equal to minus 30. Got? Third one. Minus 3, A equal to minus 3. A2 equal to minus 2. A3 equal to minus 1. A4 equal to 0. So what's A2 minus A1 minus 2 minus minus 3. It's being minus 2 plus 3. How much? 1. A3 minus A2. A3 minus 3 minus A2. A3 minus 1, sorry. Minus 1 minus 2. Minus 1 plus 2. If you can find out all where common difference is same, so that given sequence in AP. This in AP, this in AP, this in AP, and here 3, 3, 3, 3, 3, 3 repeating again and again. So A1, fourth part, 3. A2, 3. A3, 3. A4, 3. So A2 minus A1, 3 minus 3, what's 0? A3, A2, 3 minus 3, 0. A4, 3 minus 3, what's 0? Common difference, what? D. So this is in AP or not? Definitely in AP, because common difference is same. So these are the 4 examples given to you. So we have to check next. So what's the definition of arithmetic progression? Is a list of number in which each term is obtained by adding a fixed number to the preceding term, except the first term. What's its meaning? 3, 5, 7, 9, 11, 30. So about first term we don't know what, how much adding in it, but after this we can write 3 plus 2. 3 plus 2. Here 5 plus 2. 7 plus 2. 9 plus 2. 11 plus 2. What's common? 2. So that's why this definition is this. So the arithmetic progression is a list of number, or you can say is a sequence in which each term is obtained by adding a fixed number to the preceding term. Preceding term here, in 3 adding 2, what's coming? 5. 5 2 adding, what's coming? 7. Here adding to 9 coming. 9, 11, 13. Its preceding term is this, preceding term, and 5 is the succeeding term of 3. So here we can say about talking common difference, that's 2. A is the first term, 3. Common difference, A2 minus A1, this we can say A1. So 5 minus 3, which is equal to 2. So if anybody is saying what's the definition of AP, so you can say AP is the arrangement of the number. AP is the arrangement of the number in which adding a fixed number to the preceding term, except the first term. Understood? Another example, 6, 10, 14, 18, 20. Here is the first term. A2, 10. 10 we can write 6 plus 4. A3, 6 plus 4 plus 4. Or this we can write 10 plus 4. So here 4 is the fixed number which we are adding for finding the succeeding term of a preceding term. So understood? So first term always denoted by A, common difference D. So I think you understand with these example what is AP. So many example later on also, but general idea in your mind. So what's the definition of a arithmetic progression? We can say like this, it is a sequence. This is a sequence where adding fixed term to the preceding term of the succeeding term except first term. Or we can say, what we can say, arithmetic progression is that form of the number, arrangement of the number, where adding a fixed number to the preceding term number to find out the succeeding term of the preceding term. Like this 3, 5, 7. So in 3 adding 2, then this it's succeeding term of 3 coming. And 3 is the preceding term of 5. Got it? Common difference is this. So here given, what's given? This given. The height of some student of a school standing in a queue, in a row you can say, in a line you can say, in the morning assembly. First student is this 147, then 148, then 149, then 150, then 151, in this way last one 157. So we have to tell, what we have to tell, it is in AP or not. So we can check. We can say A1 or we can say this 147. A2 148. A3 149. A4 150. A5 151. Remaining also we can put like this. So find out A2 minus A1. A2 148 minus 177, what 1? A3, A2 149, A3. How much? 1. A4 150 minus 149. What's 1? So here, what? A2 minus A1 equal to A3 minus A2 equal to A4 minus A3. Continues like this. So the given sequence definitely in AP. Why? Their common difference is same. First term is denoted by A. Understood? A or A1. Got it? The minimum temperature in degrees Celsius recorded for a week in the month of January in a city arranged in ascending order. So in this way, 3.1 minus 3.0 minus 2.9 minus 2.8 minus 2.7 minus 2.6 and minus 2.5. One thing I want to tell, so in this way, this is wrong. Always coming here, 2.7. This also kept in your mind. It's very important. Understood? So same process, What we can say, which one is the first term? This a1 minus 3.1, a2 3.0, a3 minus 2.9, a4 minus 2.8, a5 minus 2.7, a6 2.6, a7 minus 2.5. So check one time, what's a2 minus a1? a2, this, minus 3.0 minus 3.1. So how can we write like this? This is minus 3.0 plus 3.1. So which is equal to 0.1. Which is 0.1. How can came this? I think you know easily. So similarly, if you can calculate a3 minus a2, which is again equal to what? a2. a2 is what? 3. a3 minus 2.9 minus 3.0 is equal to minus 2.9 plus 3, which is again 0.1. So if you can find out a3 minus a2, a4, a3, which is also 0.1. a5 minus a4, that's also 0.1. That's also 0.1. So what's here? Here is this a2 minus a1 equal to a3 minus a2 equal to a4 minus a3 is shown. So definitely we can say the given sequence is in AP. Given sequence is in AP. Why we are saying sequence? Because we can write with the help of these next term. What's the next term? Minus 2.4. Next also able to write. So that's why it is a sequence. That's why it is a sequence. Understood? So the total saving after every month for 10 months, when 50 are saved in each month, 50, 100, this is left as exercise for you. Explain why each of list above is as an AP. You can see that. So look one time, 50, 100, 150, 200, 250, 300, 350, 400, continuous like this up to 500. So what's A here? 50. A2, 100. A3, 150. A4, 200. A5, 200. And if you can find out A2 minus A1, 100 minus 50, easily you can understand. If you can find out 150 minus 100, if you can find out 200 minus 150, how much? 50. How can 50? Common difference is same. So that's why this in AP. So another part I can tell. Now this written, I am saying, what is this? This is A. I have A equal to 50. And what's D here? D find 50. So this we can write A 100, 50 plus 50, 50 plus 50. This 50 plus 50 plus 50. This 50 plus 50 plus 50 plus 50. This is 50 plus 50 plus 50 plus 50 plus 50. We can write like this. So we can arrange like this. This is, what is this? A. This I have written A plus D. This I have taken A. How many D? Plus 2D. D plus D. This is A. How many D? Plus 3D. This is A plus 4D. A plus 5D. What's its meaning? Its meaning A2 is equal to A plus D. A3, A plus 2D. What's A? A is the first term. And what's D? D is the common difference. What's A4? A plus 3D. What's A5? A5 is equal to A plus 4D. How can this came? How can this came? I can tell. I have taken A5. A5. And this we know, A4 plus D. A5, A1, 2, 3, A4, A5. This we have written 200 plus 50. 200 meaning A4 plus D I have written. Understood? And A4 I can write A3 plus D plus D. Yes or no? And A3, A2 plus D plus D plus D. And A1, A2, A1 plus D. How many times D? So what's it's become? A plus 4D. So formula become in this way. Which formula? This formula. A plus n minus 1 into D. This I have written. This is what? A5. This how can I write? This I can write A plus 5 minus 1. 5 minus 1, 4D. And if we are having n term, an plus A is the first term plus n minus 1. If we are having finding nth term, so n minus 1 into D. Its meaning is this. If we are having giving first term, number of term and common difference, then easily we can find out any term of the given sequence or this given AP. Understood? So this is the generalization of it. So example number 1. Example number 1. This is for this given. Write the first term A and the common difference D. So this given 3 by 2. Solution of it. 1 by 2 minus 1 by 2 and minus 3 by 2. Write the first term A. So first term is what? Already you know. A 3 by 2 and common difference also you have to find out. So we can say A1 equal to 3 by 2, A2 1 by 2, A3 minus 1 by 2, A4 minus 3 by 4. So find out A2 minus A1. What's A2? 1 by 2 minus 3 by 2. Yes or no? What's LCM of 2 and 2? 2 is your LCM. 2 divided by 2, 1 coming, 1 multiply here, 1 minus 2, again 1, 3. Minus 2 by 2. Cancel. Minus 1. Again find out. A3 minus A2. What's your A3? Minus 1 by 2 minus 1 by 2. Solve it. 2 is your LCM. Minus 1, minus 1. So what's minus 2 by 2? Cancel. And if you can find out this, then also minus 1 comes. So here what? Here A2 minus A1 equal to A3 minus A2 is equal to A4 minus A3. You can calculate all are equal and this is equal to B and this is equal to minus 1. So what's common difference? What's common difference here? D equal to -1 of this sequence. Understood? So in this way you can show. Next example given. Which of the following list of number form an AP? If they form an AP, write the next two terms. First you have to tell these four parts given which are in AP, and if these are in AP, find its next two terms. So look one time. So first example I am taking from here. 4, 10, 16, 22. A equal to 4, 1 you can see. A2, 10, A3, 16, A4, 22. And this A5 we have to find, sorry, this later on I can write. So find out one time A2 minus A1. A2 minus A1 minus A1. A2 10 minus 4, how much? 6. A3 minus A2, 3. A3 how much? 16. A2 10, 6. So common difference is same. So here B equal to 6. And we have to find out next term after A4 what's coming? A5, A6, A6. So A5 is equal to A plus 4D. Formula is this. Directly also we can find out 4, 10, 16, 22, 28, 34 like this. But we can apply AP, A5. So A5 is equal to what's? A, 4 plus 4 into 6. How much? 4 plus 24. How much? 20. So this is A5 equal to 28. Similarly, A6, 34. So this first one is in a AP. First one is in AP. Then what's taking? Second part you can take. Second part you can take. What's given? 1, -1, -3, -5. So you can check A equal to 1, A1, A2, -1, A3, -3, A4, -5. So what's A2 minus A1? A2 -1, -1, this. -2 is this. Similarly, find out A3 minus A2, A3 -3, -1. So what's it's become? -3 plus 1. So -3 plus 1, so how much left? -2. Look one time, these are equal. One more you can check, A4 minus A3, A4 -5 -3. So how much? -5 plus 3, again equal to -2. So what we can say? We can say like this, here A2 minus A1 equal to A3 minus A2, here -2, this equal to A4 minus A3, which is equal to what? -2, and this is saying B, common difference. We have to find out what? A1, A2, A3, A4, we have to find out A5 and A6. So A5 is equal to A4 plus B. A4 is what? A4 -5. -5 plus -2, D is this. So how much become? -5, -2, -7. One more way by which we can find out A5. A5 equal to A plus 4D. What's your A? 1. 1 plus 4 into D is -2. So 1 minus 8, again -8. Similarly, we can find out A6. A6 is equal to A5 plus D. What's A5? -7 plus -2. So it's become -7 minus 2 is minus 9. So this is also in AP. This is also in AP. Third one, we can check. We can check third one. Third one is this. Third one. What's minus 2 to this is third part of this. What's given? 2 minus 2. Minus 2 given. This is minus 2 plus minus 2, 2 minus 2. It's meaning what type of AP is this? Infinite AP, going to infinites. What's A here? Minus 2. A1. A2, 2. A3, minus 2. A4, 2. So find out A2 minus A1. A2 is 2 minus 2. How much? 2 plus 2. How much? 4. Yes or no? A3 minus A2. What's A3? Minus 2. Minus A2. 2. 2 is this. What is this? 2. So what's coming? A3. What's A3? Minus 2. A2. 2. So this is become minus 4. These both are not equal. These both are not equal. So what we can say? A2 minus A1 is not equal to A3 minus A2. Hence, the given sequence is not in AP. If it is not in AP, how can we find out its next term? We can find this. We know it's following a rule. So definitely a sequence, but not in AP. One more question given to you. This 1, 1, this is given. Fourth part. 1, 1, 1, 2, 2, 2, 3, 3, 3, and this. Again, I can tell this. What is this? This is infinite GP. First, we have to tell this is finite GP or infinite GP. But this is going to infinity. So this is not a infinite GP. And I already told you, if contain finite number of terms, then finite AP. And if contain infinite term, then infinite AP. So check one time here. A1, 1. A2, 1. A3, 1. So A2 minus A1. What? 1 minus 1, 0. Okay. A3 minus A2, 1 minus 1, 0. A4 minus A3. What's A4? A4 equal to 2. So 2 minus 1, which is 1. So what we can say? These all are equal, no? So we can say A2 minus A1 is not equal to A4 minus A3. Hence, the given sequence is not in AP. This is all about, it's basic of it. Tomorrow we will discuss. You will try to solve this formula AN equal to A plus N minus 1D. Its derivative I need. If you able to solve. If not able to solve, tomorrow I can tell. Tomorrow we can start the exercise of it. And if any example left, that also I can tell you. This is all about this chapter. Tomorrow again we will meet. Thank you all of you.